Hello there. Welcome to the last video in my Gophin off with linked list series. This is the one where it all comes together. The other videos have been building off of each other quite a bit. In this one though, I'll put it all to work while learning new stuff still. Specifically, I'll be building a very simple web service app that manages prioritized tasks. Alright, so let's get to it. So first, a quick review. In the previous videos, I've mostly built out this data structures module here that mainly contains various linked list implementations. The core implementation is that of a circular doubly linked list, right? Then I have another implementation that leverages off the core one, but the twist here is that elements are sorted in their natural sorting order rather than the insertion order that this guy stores them in. All right, and then finally we have a third implementation in the concurrent package. And what this one does is it takes any other version of our linked list and then makes them thread safe. And of course we have a base.go where we have all the interfaces, things need to be compatible with. Your linked list implementations are all compatible with this guy. The iterators they expose are compatible with this guy. This is only used by the sorted linked list, but it's sort of an exposed abstraction or something that values being pushed into that linked list implementation need to be compatible with, right? Okay, so we've done and seen quite a bit, right? Because in the process, we've also tested all this code. We've figured out how Go unit testing works, how coverage and all that stuff is built into the standard Go install, which is awesome. But all that we have done is still pretty abstract. This is all library code. We're pretty much in abstract data structures here. We haven't done anything real tangible that like a non-programmer could understand, right? So let's use all this to build a real application, something close to one anyways. This might not be something that'll earn a lot of money or anything, but this will be an app that will make things more tangible, right? So in this video, relying completely on the data structures from the previous videos, this guy, everything here basically, and then we'll also use Go's built-in HTTP support. They're sort of the built-in web app framework essentially, or library, whatever you're gonna call it. I'll go ahead and build a simple web service using all that, and this web service will just manage tasks, a to-do list, if you will. I know, a very, very innovative idea in programming, right? Well, we can use this service to store a bunch of tasks that we want to do, and then we will assign these tasks priority. So we can throw these tasks with some priority on each one in whatever order into the service at whatever time. And then the service will make sure that when we ask it what task we should do next, it gives us the highest priority pending task, right? So before we start writing code, let's figure out what specifically we are building. So since it's a web service, I'll go ahead and model the accessible endpoints and data that will be exchanged with them. So let's go ahead and get started. Instead of going into data structures now, let's create a new top level folder, and I'll call our app taskmaster, right? And let's just go ahead and create that. And then in here, I'm going to put in a main.go file. And this will be the entry point into the application. But before we write code, let's just go ahead and put down in comments essentially what endpoints this application will expose and what data those endpoints will exchange. All right, so here are the endpoints. Our taskmaster will keep things simple for now. Now there are two endpoints that each support get and post HTTP methods, as you can see. So first we have the task endpoint, and a post here creates a new task, right? And you post a JSON body to that post endpoint, and the structure of that JSON payload is given here. You basically have a name, a description, and a priority, which is an integer, and that makes up the data fields required to represent a task, right? Cool. Doing a get on this endpoint will allow us to peek at the next highest priority task, but doesn't really pop it off. It's just available. We're just seeing what's up next, right? Okay, so what does a taskmaster do with these tasks? It assigns them to people, right? So now our taskmaster is going to be a bit of an egoist. The taskmaster doesn't reach out to its people. The people reach out to the taskmaster. Okay, so people looking for work can call the get on task assignments here, the second endpoint, and it'll take a query param with their user. and that's how the caller, the user that, or the person who's asking for a task can say, this is who I am, give me a task, right? And as long as they don't have a task assigned to them, they get the next highest priority task. Awesome. And then when they are done working the task that they were assigned, they can post again to this endpoint with their username, and the taskmaster will say, okay, looks like you're done with the task, you're free to go. And then now they can call get for the next task. Cool. So the first thing should be obvious here. I'm not giving a rat's ass about security here. But I will do some error checking and validation, as a person already working on a task shouldn't be able to grab a new one. Someone who is not working on a task shouldn't be able to say they're done. So we'll do that level of simple error checking and validation and stuff. But yeah, no security. You can be whoever you want to when you make the call. There's no authorization or authentication layer here. I just wanted to get into that. A production app needs that to just build something, to see something working. We don't. So we're going to stay away from that. Okay, so let's start writing some code. I'm going to organize my code in two top-level directories underneath Taskmaster. I'm going to have an HTTP package as well as an impl package, short for implementation. Okay, so the HTTP package will implement all my HTTP-specific concerns. Easy, right? So it'll expose the endpoints and all the jazz related to that, any JSON, serialization or deserialization. Any sort of other helper functions that need to go along with to purely support the HTTP layer of our app. All that stuff will go here. The impl package is the brains of our operation. Here we will implement the taskmaster without worrying about the HTTP layer through which it'll just happen to be used, right? So this is basically an exercise in separating concerns. In essence, keeping our abstractions modular and focused on specific purposes. And that's just a good way to architect and organize your app. And we'll do that even in our simple little app. Okay, so let's focus on the HTTP package first. Without worrying about actually implementing the taskmaster requirements, I just want to build out a skeleton or a demo version of the app that doesn't do much, but the endpoints are usable and they're active if the app is running. Okay, so let's do that. So first we have here a common.go file. In here I'm just going to put stuff that's common to the package, right? So things like data models and helper functions that the rest of the package will use and leverage, right? So what do I have here? First, I've modeled the task JSON structure we were talking about earlier as a Go struct. Now, do note that all my fields are public. That is important to have the encoding / JSON package do the serialization from Go struct to JSON message properly. It needs to have visibility to the data fields. So I can't keep them private. That's what it is, and you'll see that here as well. In contrast, you will notice the types themselves, the task here and the error message that I'll talk about in a second here, those I've kept private. That's because I don't intend to use this stuff outside the HTTP package. This is not library code to be used by anything out there in the world. It's not general purpose stuff. This is a specific HTTP layer of my specific application, right? And my philosophy is always hide things as much as possible unless you absolutely need to expose them. Because when apps evolve, when code evolves over time, is touched by many hands, and it starts getting used by many things, or starts getting used in production, starts getting entrenched, it's always easier to expose things that you should have exposed but were kept hidden than it is to expose things willy-nilly in the beginning and then try to hide things or change things. Because if you put it out there and it's public, chances are, especially if a lot of people are touching that code, somebody's going to start using every single piece of your public public code. So that's just my philosophy. That's what I'm going with. So in the HTTP package, you'll notice most of the stuff here is going to be private and internal to the package. Cool. So moving on, I've also created an error message. Now this is new. This is something I didn't talk about, but it's a good practice I kind of use in most of my code, most of my web application code really. I tend to create a consistent error message if one doesn't already exist on that project or that product line or whatever, so that all the error messages that are sent back by a web service or a collection of web services are consistent and intuitive. So here you'll notice everything is public again, and we've got a status code, which is going to be the HTTP status code associated with that error message. This is going to be something like whether it's a bad request, internal server error, if something is just unauthorized, things like that, right? And then there's a helpful error message. This is something brief and just kind of captures what the error is. And then if there's any detail, that's get thrown into the detail part, right? So I've created that error message. And then I have a set error response helper function that can be used by anything in the package to essentially say that I'm going to send an error response back. Here's the error message. They can just capture the detail here and have this method worry about conversion into an actual HTTP response from this Go struct, right? So with that comes our first encounter with Go's HTTP package. So I'm not going to dig too deep into Go's HTTP package, which is different than my HTTP package. We're putting things, they just happen to share the same name because they're concerned with HTTP, right? But I'm not going to dig too deep into Go's HTTP package because in my opinion, it is too low level to be a productive web framework. Now, a lot of people have already written Go off as a good language for web services, period. It's competing with things like Java or C#, .NET that have just such a huge ecosystem, so much good library and third-party or even first-party language support out there for building web services that it's hard for Go to compete. I do think it's a better alternative than like Node.js for server-side applications. But even if you're writing web services in Go, the HTTP package shouldn't be what you're primarily relying on. There's a lot of good higher level web frameworks out there in Go that you should be using instead. So I didn't want to get into any third-party web framework because then you have to deal with that learning curve. So I'm just writing something very simple, and it's a good way to kind of expose things because all those things eventually end up depending on the HTTP package to do what they're doing, right? So it's a good thing to go ahead and kind of look under the hood for a second, and just be aware of what HTTP offers because you never know when you might need something or when you might encounter something. But other than that, I'm not going to dig too deep into HTTP. So with that in mind, I'm just going to go breeze through the HTTP stuff here. The response writer here is an abstraction that's exposed by Go's HTTP package to manipulate HTTP responses. This is how you say the HTTP response going out is going to have this body or this HTTP status code, these headers, things like that, standard HTTP stuff, right? Okay, so here in set error response, you see we can take an instance of the error message struct from above and construct a proper HTTP response with a JSON body and appropriate status code and all that stuff, right? Now the JSON serialization I'm doing with my own set JSON response function, and that is a great segue into the next part of the file, the helper functions. Cool. Here I'm leveraging the encoding/JSON package I was showing earlier. And leveraging that, I've created two functions, one for serializing data, which is a set JSON response, and one for deserializing data, which is parse JSON request. And that's essentially your out and your in, right? Now here I'm saying set instead of create or construct or something like that because we're actually setting this JSON response directly on the response writer. The way the Go's HTTP abstraction works is easier to just kind of take in the response writer and just set things on it rather than return something because you've got to call all these methods on the writer, right? You see a lot of w.header set, w.write header, w.write. So it's easier for me to be like, I'm going to set the response on the response writer you give me rather than I'm going to have more of an idempotent sort of a function that just takes in something and transforms and returns something. I will create a transform function later to contrast how those two can differ in philosophy as far as how you create functions, right? Okay, but just wanted to put that out there. And you'll see similar stuff here with the parse JSON request. It actually has to take an interface, and this is an artifact of how the JSON package works. It doesn't return things, it populates things, right? So you basically, sorry, this is what I should be looking at. So you basically configure your decoder with the data, and then you decode into something. And this method is not taking this as an input; it's actually using it as an output, and as a container to populate stuff into. And it better sort of match the JSON you're expecting to parse and stuff, right? So those are the two functions. I'm not going to go into too much more detail than that. Just go ahead and read the documentation. This is standard HTTP stuff, just how Go does it. So there, if you're coming, from any sort of web service background, nothing here should surprise you. This is just a low-level way in Go to get your HTTP stuff done. So on to more interesting stuff. How do we use it? So for that, let's go to our task-controller.go file where we implement the /task endpoint. So I've created that here as well. So let's go through that now. Actually, before we go through this file, let's build another file first. So I'll call that file server.go. Now this is sort of the entry point code for our HTTP package. Here we lay out how the HTTP layer works from a high level. Here we will use the http.handleFunc method to associate endpoints with their handlers. And that's sort of a pattern that if you've done more lower level programming other places, you probably might have seen. But it's just, associating. Most modern frameworks kind of start doing these things with annotations and stuff. So some of that lower level detail is hidden from you. But this is more or less what happens under the hood in almost all web service frameworks out there. So what do we have here? We'll go ahead and create it's a package HTTP, right? And then we'll go ahead and create a struct here, just a simple one called server. And do note that I am capitalizing the server here because this is going to be the only real exposed type of this entire package. And we will call this function on it, which is run. Sorry, and that's also public. So this is essentially how our main method is going to go ahead and instantiate the HTTP server that can start fielding requests, right? And here we'll come in and create the controllers, which are actually the delegates that handle specific endpoints. Cool. And right now we just have a task controller, right? And task controller is obviously going to be our task controller, which doesn't have any state yet. That'll change once we actually implement our impulse stuff here, right? They'll start leveraging that logic to actually do all the work. Right now we have a skeleton. And then we go ahead and register our handlers. And the code here will make sense in a second once I go back to explaining task-controller.go. But let's go ahead and use the http.handleFunc to provide our handler functions. So what do we want to do here? We want to do task. So any request that comes to the /task endpoint, we send it over to task controller. And it's not really, we don't send it to build handlers. We send it to the function returned by build handlers, right? And we'll look at that function in a second. The last thing we do here is we start our HTTP server. And this is sort of a Go community thing that I've noticed. I don't know enough about this log.fatal line here. Talk intelligently about it. I assume basically the log.fatal is called because we want this HTTP server to be running forever. So anytime this line here, the whole listen and serve, and I'm going to start things on 8080. Anytime this actually returns, we're just going to assume something fatal happened because it's literally the server is dying and we're logging it. But I don't know enough about this yet, so don't take my word for anything yet. I need to go research that more fully myself, why this specific pattern was born, right? All right, so we need some comments. So the server encapsulates the REST API for task master. And I'm calling it REST API, but it's not really RESTful the way we're handling assignments. The way we're handling tasks obviously is, but the way we're going to do assignments later on, that kind of is borderline. But that's real world. You see that all the time. All right, and starts the server. This function will log. Sorry, not initialization, termination. Awesome, cool. So as you can see, our server is kind of straightforward. We come in and we basically associate endpoints with their handler function returned by this build handlers method. And I'm calling it handlers because there's not just one handler, right? As you'll quickly see, you're going to have different HTTP methods. And then we just kind of call this guy this will just run forever. This is the Go stuff that's happening under the hood, running the actual HTTP server, right? Cool. While we're at it, I'll go ahead and just update my main method now that I have my server here, right? And so I can go ahead and instead of using this implement me log here, we can go ahead and instantiate our server, which will be from the HTTP package. And it doesn't take any state yet. That'll change later. And then we just do server.run. Sorry, not that guy. Boom. I didn't realize it would be that explicit. Something I just forgot. But that's why you have real-time compilation error checking in your IDs, right? All right, so now we're ready to go back to taskcontroller.go. So you can talk about that more intelligently. So as you saw, we are using this method to register, the return of this method to associate the task endpoint with all this logic. So what are we doing here? So here we have a switch statement that builds cases for each supported HTTP method. For unsupported ones, we fall into this default block, and that gives us an error message saying the method is not allowed. Cool. And for the supported ones, we have a handle get and a handle post, kind of like what we decided here, right, based on this design. In handle post, which is at the very bottom here, we'll cover that first because here we log and cache the task that was sent in as the last received task. Now that is held on into the controller's instance state by what we're setting this task struct pointer here. Now this is not sophisticated task master implementation stuff just yet. This is a skeleton. We're gonna get there, but we gotta crawl before we ball, as some have said, right? So do note though the use of our helper functions here, right? Because whatever we're parsing in our handle post, and then we're just echoing back whenever the get is called as whatever was sent back as post last. And we're using our parse JSON and set JSON fabulously here. Do note this pattern here that I think we didn't really use in our data structures package at all. This is library code and it was kind of low-level data structures. So I just wanted any error case to kind of result in a panic because I didn't want the user of a linked list to keep error checking, because if you know what you're doing, I'm kind of more or less guaranteed that things will work there. Whereas here, we don't have control of the data. This is a web server. Somebody can come in and for whatever reason lead to some bad data coming in. It's very likely that there will be bad requests coming here all the time. Maybe not, but there can be, and we got to be ready for that in our server side, right? So here we use more of an established Go pattern for dealing with expected errors. And here we say we're going to call this parse JSON request, and this will tell you whether it succeeded or not by setting this flag here. And it's actually an error type. That's an actual built-in Go type that's being sent back here. And so if unmarshal error comes back non-nil, then we don't do anything further because that means something happened. Now that's another thing that I'm doing. Inside parse JSON request, I'm actually doing all the error handling in here. So basically, I'm using the decoder.decode. It sends back its own error thing, unmarshal error. And that is what I go ahead and return here as well. I'm not inventing a new error for that. But if it's not nil, meaning this decoder failed, then we go ahead and send a bad request value back, right? And then pass on the unmarshal error if somebody wants to do something with it. We don't in the task controller here. But if it is successful, meaning it is nil here, then we go ahead and log and echo it back. Set JSON response works similarly. It also goes ahead and looks at the error sent back by Marshall, and if there is an error, it goes ahead and sends back basically this internal server error. Now here, I'm not throwing back the error just yet. First of all, it's an internal thing, and this is the cool thing about internal stuff, right? Because not much is going to start using it right away. So usually the set JSON response is the last thing I'm going to do in my things. That's not the case with parse JSON requests. It's usually the first thing my methods are going to do. So I've just made a design decision right now that I don't need to worry about the return value here, so I'm not sending it back. If I need to, it's going to be pretty easy. Just throw that here, throw that there. Sorry, throw the return type here and throw the return statement there, right? But here, as you can see, is the last thing that happens, so I'm not going to do anything with that error anyways. There's no decisions to be made. And this guy, instead of sending a bad request, just sends an internal server error because it assumes it was an error that we didn't really catch, and it happened when we're actually doing something. So there's probably a coding error or some sort of a compatibility issue that's really a server-side issue. And so we send an internal server error there. Awesome. Cool. So now that we have seen the pattern here, let's go ahead and do the same thing with our task assignments controller. And then let's start building out our actual implementation because it's about damn time, right? So I've gone ahead and created task assignments controller already, not doing much here at all. So I don't want to have you sit through all of it as I typed it out. So I'm just logging when a get or post is called, not doing much at all. If you call the get method, it logs get, called post method, calls post. Everything else should look very familiar to the task controller we did. And obviously I went ahead and updated the server.go file so that it instantiates a task assignments controller and then registered the correct endpoint to it. So nothing really new here that's going on. So really the best way to dig in here is just go and fire things up. All right, so do that. I'm going to go ahead and go to my source local taskmaster. And then I'll go ahead and do a go build and run taskmaster. The executable will be named after the folder. And you can actually even see from a previous iteration when I was testing it, it's there. And then I'm going to go ahead and run the taskmaster application in the background because I'm going to then start using curl to talk to it, right, as my HTTP client. So it's that fast to get it up and running. That's why Go is so celebrated for its speed, because I mean in Java, build, getting it into an executable takes about a minute sometimes, whereas boom, Go is ready and it's running and it's pure executable, right? Awesome. So how do we test this? Let's use curl. So first, let's just go ahead and test the assignments controller. So we're running on localhost 8080 is our address, right? And then we have task and then assignments. Now, if you've done everything right, that should work, and it does. We get a get called. Now, how do we go ahead and do a post? We do that, and you get a post called. And so the server logs things first because that's not something that's happening as a result of curl. That's just what the process is logging, what we send in the background. And then the curl, I passed in an I option here to get the HTTP response detail. So I get my status code, what time it came back, and all that, and the content length. I'm not sending back anything, right? I'm just logging things and just returning. So by default, that's assumed to be a success, and a 200 gets back. Cool. So that's working well. All right. Now we can also go ahead and test the put method and see how that differs. So remember, we only support get and post. So this is an error case now we're doing, right? So when we send a put, we get our nice little error response saying, hey, the method is not allowed. And you see the status code that we are trying to set does get set on the response. Curl tells me, hey, I got a 405 back on this thing. And the content type is set correctly and all that stuff. Just wanted to show that as a quick exercise, right? And let me just do that in a more pretty way because curl doesn't include a line break at the end. But yeah, that's the error response that came back. And we can show that the same thing happens on a delete. All right, because delete is not supported either. Next, let's go ahead and test out our task. And I'm actually going to do a get on this one. Now I'm going to include get. If you took off the X get part, then it would be a get by default anyways, but I'll just keep it consistent. And everything is good except we get back a null, and that's expected because if you remember in task controller, we've got this last received that we don't initialize to anything. So the 0 value of the pointer type here ends up being nil. That nil gets encoded, and that didn't really throw an error, which is kind of good on encoding /JSON, but it does come back as a null. All right. So let's correct that. Let's go ahead and post a task. How do we do that? We can use curl for that again. So we'll go ahead and post. No, sorry. We'll set the header type to be JSON, content type. And then we'll pass in some data, right? So we'll give it a name. For name, let's call it test task. We'll give it a description. And for that, let's call it, some test task we just created. All right, and then finally, let's give it a priority, capital P. And let's just say 25 for good measure, right? All right, so we are posting, we're sending some JSON data, and here's all our JSON data that should match the internal task type. That's all we should need to do. And boom, we get that received task log, awesome. And then after that, curl tells us it's a 200. And on the post, we don't send anything back. Now, ideally, we should be sending a 201. But I haven't gone through that because on a post, when you end up creating data, you should send back a 201, which is created is the status, right? But not a big deal. It's not a production app, right? We're just getting our bearings. All right. So now when we go ahead and do our get again, now we get back what we just created because we hang on to it, we cache it in the server, right? Cool. So our skeleton is working. Our dumb little HTTP skeleton is working very well. So now we need to make it smart by building out the actual implementation layer. So let's do exactly that. Boom. So how do we implement the task master? So here we can actually use a sorted linked list from way back we already built to do all the heavy lifting, right? It is the sorted linked list is very good at letting its user dictate how elements sort, and then once it knows how elements should be sorted, then it's very good at enforcing the fact that all elements stay sorted, even as new elements are added into the list, right? So knowing that, if we sort tasks based on priority and creation time being used as a tiebreaker because you want to favor older tasks over newer tasks, then we can rely on the head or tail of the list based on how you end up sorting things to give us the oldest task with highest priority, right? So I have done exactly that. As a quick refresher, we can go back to data structures package here and look at the sorted linked list. That's what we're really going to rely on to do the sorting for us. So this way we can always keep tasks stored internally in a priority-based order so that you don't have to figure out on every call, well, what is my highest priority now? What is my highest priority now? They're already sorted up front, and that's exactly what this list does. And we tell it how things should be sorted by implementing this interface in the type that we insert into the list, right? Cool. So I've gone ahead and implemented the whole thing already in the impl one because there's not that much new Golang wise that we're just kind of adding here at this point, right? So I don't want to sit here and type it live, and instead we'll just go through the types that I put together. So let's look at task.go. This is very similar to the task type we defined here in HTTP and common.go, right? Remember this guy? But while this guy is built to be very friendly to JSON encoding and decoding, and it's really built so that it's something we know is going to be very, very easy to turn into JSON and turn back and parse from JSON. That is not what this guy's intended for. He's not going to be as friendly to do exactly that. Instead, here, this is more of a data object for our task master implementation. And where it differs is it doesn't have every field visible. It has an extra field called created at, which might as well be kind of hidden to the caller, right? It hides these things because it doesn't want you changing them, because they kind of dictate how tasks sort naturally. And if they're allowed to change willy-nilly, well, you could have a task inserted in the list, and then these things, and I'll show you how, will kind of affect where an element gets put into the list. And then if something just goes and willy-nilly changes the value of these things, well, now the sorting is no longer valid, right? So make a design decision that these things are essentially final. Once they're set, they're set. You cannot change the priority in a task. You cannot change when a task was created. Now, obviously, that might not be the most useful thing, and if it was an absolute requirement that task priority needs to be changed, you would work around that, come up with a better algorithm or an implementation. Here, we'll take the easier route, right? Cool. And then if you do want to look at the priority or the created values, these methods, expose them out, but keep them uneditable. And then really the most interesting part of this this file here is going to be this compare method. And here you can see that we are sorting by using the priority and created at values. Awesome. So the way this ends up working out is priority sorts normally. If you remember, if the receiver is greater than the argument, you return a positive integer. If it's less, then you return -1. If it's equal, we would have returned 0, but we return 0 if they're exactly equal, meaning the created at is there as well. But if priority is equal, we use created as a tiebreaker. Created at sorts things in a reverse order. So when the receiver is greater than the argument, we actually return a negative integer. So what ends up happening is the way things get sorted is tasks with low priorities go to the top of the list. Tasks with the highest priorities go to the end of the list. Tasks that are older end up going to the end of the list. Tasks that are newer, meaning they'll have a greater timestamp, end up being to the top of the list. So this way, if you have a high priority or you're an old task, you're at the tail of the list. And that's exactly what we want, so that we can go to the tail, grab the task from there. And you'll remember, and let me just pop up the base.go here as a refresher as to how this works, right? And then obviously the get on the tail or the head of a list is a constant time operation, no matter how big that list is, right? And that's one of the benefits of a circular doubly linked list. So we leverage all of that to get ourselves a task that will really help us out. Then I created a task list.go, which goes ahead and is a nicer abstraction. So you don't have to, anything that wants to deal with this task stuff does not have to build out its own list. It hides a linked list inside it, and then externally it just exposes some nicer operations where you can add a new, they're kind of more task-centric operation, right? The task abstraction we have created. So you can add a new task where you just give it the data, it'll create a new task, add it to the list, and return it, right? Or you can deal with the task abstraction directly. Then it'll give you things like pending count, what is the next one without removing it from the list, or doing a next, which will give you the next task and remove it from the list. This is kind of a cool thing. I had to do a resolve nil or task, and that's because this delete here or this get here returns an interface type, because this list is a general purpose list. It's able to accept types of accept values of any type. Here we're returning a task type, a pointer to a task type, right? So that works fine. I could have just basically put this downcast right here, and that would have worked fine until this or this returns a nil. And when that happens, then you get a cast exception saying, hey, I just got a nil, you cannot cast a nil, is what Go says. And so there we have to kind of basically account for nil. And so that's why this guy exists. Cool. And so that's task list. It's a nice abstraction around a more general purpose linked list. You'll notice that it has one create method. It's a create prioritized task list. And what this guy returns is it takes the sorted linked list, creates that using its create method, and then wraps that linked list with a concurrent list. So you get a concurrent sorted list is what it has internally. So when it's calling these add methods, this task list, the internal one, is a concurrent sorted list. So it's thread safe and it'll keep elements in a sorted order. Cool. So that's the thing about the task list. And then finally we have the task master. So this is what's actually going to get exposed out, or I mean everything's exposed out, but this is actually what is going to get used by our HTTP package. The top level abstraction, we'll just instantiate one of these guys. And here, I think for the first time we're dealing with maps in Go. And this is to keep track of what task is assigned to who, because we have user-based stuff here. So here we'll go ahead and create new tasks, assign tasks given a user. So create basically just adds things into the pending queue or the pending list. Assign actually goes ahead and assigns them out, so moves it out of the task list and assigns it to somebody, makes it a live task being worked by someone. Peek next is just a way to get the next pending task. Peek assigned is to show what is currently assigned to somebody. And then unassigned I put it here, although I don't think we have a use case for it. But it's an operation there because it's easy enough to implement where you can unassign a task but not mark it done so that it gets moved back to the task list instead of just getting dropped on the floor saying this task is done. Mark done is what we're actually going to end up using given our current design, and where you actually go ahead and say somebody's completely done with it. Awesome. You'll also notice error, that whole pattern of returning an error in case of errors being used all over the place here. This is kind of interesting. So you do this when you realize, so this unassigned here returns a tuple, right? It returns two different things. It returns the task that just got assigned and returns an error, meaning if there was an error or something. When we are doing a mark done, we only care about error. And so we ignore the return type because if there is no error, we don't care. And then this leaves all the error handling to the caller anyways. So if this unassigned fails, mark done will just throw the error back out. Cool. So that's really it for Taskmaster. I've got tests for everything so that basically if we do source local test all.sh, this guy will pick up these unit tests, and we can see that our local taskmaster impl does have 100% test coverage, and that's just testing all this functionality that I just went over. A quick reminder as well, I have all this code on the GitHub page. I know sometimes I go through this, some of the stuff that's kind of more dry to type out pretty quickly, but if you want to look at the code in more detail, go to that GitHub page. I'll have a link for it in the blog post as well as the YouTube video list. And just go to that and review all the code at your leisure there. All right, but having gone through this, all that's left to do now is to update our HTTP package so that it uses this and does something useful rather than doing the skeleton stuff we have been doing. All right, so let's do that. Okay, so how do we start using the impl stuff in HTTP? First thing I'm going to do is I'm going to have this task and the impl task start being able to transform from one to the other, right? So I need to be able to take the impl task and turn it into this task. And I'm just going to write a helper function for that because while on the HTTP transport side, we're really dealing with this guy. On the actual taskmaster implementation side, we're dealing with this guy. All right, so we need kind of a bridge here, right? So let's do that. I want to call this function a transform task for transport. All right, so since we're transforming task for transport, we will take in a raw task, which is of the impl type, right? Okay, and then this guy returns a pointer to a task of this type. Awesome, simple enough. And all we do here is we build a new task, right? And what do we need? So we need to give it a name, description, priority. I have all those things in my raw task. So I've got my name, description, and then priority I'm going to have to call a function, right? Because priority is not a visible field on the raw task. I did that by design. Now the only thing missing here is, of course, this will blow up on us if this happens to be nil. So I'm going to have the function just protect itself. So if you give me nil, I'm going to give you back nil, basically. All right, easy peasy. And that works. So after that, I think I'm ready to start using the impl pretty easily. So we come back here. Let's do the task controller first. So the task controller, let's actually implement this for real. And so the first thing I need to do is get rid of this state, because this is just like a way to cache the task I received. Not very useful to be for a real web service here, right? So instead, I'm going to start using my task master here. And obviously, that's going to take my impl task master. Awesome. Cool. Now it's giving me an error because I need to clean up stuff, right? So instead of when I do a get, instead of when, so this get is supposed to be a peek onto what's the next most hot task, the pending task that's either the most important or the one that's been there the longest, right? So here, instead of returning this non-existent last received now, we can instead go to our task master. Let's see what I called it here. I did call, oh, I need to do a controller. Controller.taskmaster. And what do we call in this guy? We call peek next. Awesome. Now, this returns us a task, but this is not what we want to set on the JSON response, right? And so this is where our new function comes into play, which is transform task for transport. So we just wrap whatever is returned from here into here. Perfect. Yeah, I need to see one more. Cool. So I think it should be done there. Basically, we peek at whatever the next hot pending task is, and we massage it for transport, and then boom. All right. What do we do on the post then? So I'm not gonna just log something useless here. Instead, let's do a controller.taskmaster, right? And we're gonna have this guy create a task because that's what's happening on the post, right? All right. So task.name. And then the create here, we basically are going to give it the specific fields, so that's easy, right? And then we have a task.description, and then we have a task.priority. Awesome. And that should do it for that. Now we just need to go ahead and return something good, which would be w.write header. And I think I was complaining earlier about my post where it's creating a new task returning at 200. So let's see if we can't get a status created here. So these are kind of like your HTTP status constants here, right? Which you can use. So you also have your bad request, bad gateway, forbidden, internal server error. All those things are here as constants. Not that they were going to change, but it's a good way to have those lists there, right? Awesome. And so that should do it for our controller. So basically now, whenever we are calling these endpoints, instead of us just doing the demo stuff we were doing earlier, just caching the last received and echoing it back, we're actually now starting to use the taskmaster I created to actually prioritize those tasks that are coming in properly. Okay, so now we can do the same thing with our task assignments controller, which we actually did even less with. We're just logging, period. We're not even doing anything remotely useful there. I'm going to take a shortcut here just because this is a series that's been long enough. So I'm not going to really start worrying about actual users. I'm going to put that as a to-do. I'm going to do this when I have time, which probably will be never because this is just a tutorial, not a real project. But in case I feel it, I'm going to leave a note for myself there. And instead, I'm just going to hard code a user, which will be the only user supported by the service for now. Our original design, if we go back to our main.go here, called for a query param. I'm just foregoing this and acting like this is always so harsh. It's essentially what I'm doing. Just because I don't want to deal with the query. The query param part might be easy because of the HTTP package, but there's just some tedious, not hard, but tedious code to write. Do some error checking, make sure the the user exists, things like that. So let's just forego that. Let's just hard code a user, so we always do the same guy. Keeps things easy. We use the same state that we introduced here. All right. Cool. And then finally, we do a handle get. So what do we do here? So whenever a get is happening, that in this, the semantic here, not here, but here, the semantic here is that if no task is currently assigned to the user doing the get, then assign the highest priority task to them. And our task master takes care of the complexity of figuring out if things are assigned or not, right? So instead, what we're going to do is we'd say, okay, controller.taskmaster assign user. Awesome. And then we do a set JSON response. I'm going to copy some code here. We're going to send back a status OK, and then we're going to basically send back what is actually actively assigned to this user. And that we get by doing controller taskmaster peak assigned. Remember that function. Awesome. And I think I'm missing one more parentheses there. So what ends up happening here? Basically, we go ahead and try to assign the next pending task to the user. The task master, if you recall the logic, will send back an error if it can't assign a task. Otherwise, it will assign that task. So instead of worrying about error checking here, since the task master will not assign a task if the user already has a task, instead of throwing an error on that, we just send back the task that's already assigned to them, if they already have something assigned. If they don't have something assigned, this will succeed, give them the new task, and we'll send back what is the next task that got assigned to them, right? So this never fails. This always succeeds, and it always gives them the right task that they should be working on. So this get kind of becomes idempotent. It's not going to throw an error because you just gotten a task, you forgot that you had already gotten yourself a task, so you asked for it again. Instead, you can keep calling it over and over again until you finish the task actively assigned to you. It'll just keep echoing back that task to you, right? So, you know, it's not a shortcut. It's a good way to do it because you want to be able to have people call that get function over and over again. So in case they lose the task that they're working on, they can get it again, right? All right. So that's good for the handle get. And for handle post, this, based on our semantic from earlier, needs to mark currently assigned task to user as done. Okay. So here, what we want to do is we want to call controller taskmaster, and we want to say mark done user, right? And again, just a reminder, the user here is this hard-coded, it's harsh. Ideally, it should have been coming from the query param from the request, right? But we're just taking a shortcut there. All right, so we say, hey, you know what? Mark done this user. Awesome. Now, is that all we need to do? Well, this could return in an error. Now, if this returns as an error, this we want to echo back, saying, hey, you don't have a task you can claim to have finished. So what are you doing? So we want to echo back that error, right? So instead, we do go ahead and take the error from here. Awesome. Now we can say if error does not equal nil, then we just go ahead and set our error response, right? And we'll create an error message here. And we want to make this a bad request, right? Because this is really the user's fault. They don't know what they're doing, the consumer. So we'll send back a bad request. We'll say enable to mark done because you don't know what you're doing. And then for the detail, we'll just echo back the error. Now, this is a nice function on the error. Let's see if, okay. So I believe this is not showing me the, I was trying to get the usage of it, but essentially what it ends up doing is it, let's go to definition. No definition for error. But really what it ends up doing is essentially ends up printing out a nice, printable error based on what happened. And we'll see that. We'll test this code in a second here. All right. And then finally, and it does end up being a string. So it's like a string representation of the error that just happened, right? And we go ahead and write header. Now this is when things are good. Okay. That is okay. Okay. Great. So that should do it for our task assignments controller. Now we need to populate this guy properly. This is not just going to magically have a value, right? Right now, the way we're instantiating these things is going to be nil. So how do we get this to have an actual task master? Well, I could create one internally, right? But that's not the best practice because we want to share this instance across all of them, because the task assignments controller and the task controller need to be working with the same task master. Otherwise, you'd be creating tasks with task master A, and then you'd be assigning tasks based off tasks known by taskmaster B. Taskmaster B is never going to get any tasks because taskmaster A is getting all the tasks, right? So you want this to be a shared instance. Now, so who has the responsibility of creating it and giving it to the other guy, right? So neither of these guys should. They just have a dependency on the taskmaster, and he should really be passed in. Now, if you've dealt with dependency injection frameworks, this is a perfect use case for that. You just have your dependency injection framework take care of grabbing the instantiated taskmaster and injecting it into the right places. I'm not going to start using or implementing a fully blown dependency injection framework for this tutorial. I absolutely would for a production web service. Instead, we'll do something halfway there. So obviously the server is what's creating these guys. So the server can pass the taskmaster after creating it. So that's one route we could take. We could have the server just create it. Now, I still don't like the server knowing about them, but I'm going to make that compromise for this small project. Ideally, I would not have the server ever even know a taskmaster exists because it doesn't need to care. The server is a purely HTTP layer thing, right? I'm still not going to have the server create it for now, but I will have it know about it so you can pass it to these guys, right? And I'll explain why in just 1 second. So let's go back here and just grab exactly this. So we'll have the server carry that state here as well, and that way it can go ahead and pass the taskmaster here, right? And it's going to be server.taskmaster, obviously. That's one thing that's kind of annoying for me in Go. In most OOP languages, this would be a class. So your field wouldn't be known to exist on that instance of that class because this is an instance method. So I hate doing this whole. This is essentially doing this dot variable over and over again if you come from like Java or something, which is so verbose. And you should just have it implicit that there. I understand why you need to do it here because we're not in a class, we're in just a function. It just happens to be tied to an instance of a struct, but yeah, it's just a minor annoyance, I face it. Okay, so how do we pass this taskmaster here? We go to our main, and he will have the responsibility of joining the two essentially components of the app for now, right? As I said, ideally I would give this to the dependency injection framework because that really is where it belongs, some sort of mediator, right? But instead we have this guy do it. And we say, okay, you know what, taskmaster, I'm going to create one for you, and we'll do a create taskmaster. Still getting my hang of autocomplete features in VS Code with Go. Okay. And that gives me an error. Why? Oh, and that's because I didn't make this guy. So that's right. Now, this has to be a visible field because it's being set by main, right? The other option we have is we could have passed it to run. Instead of creating it here, we could just pass it here. I'm not a huge fan of either of these things. I'm not worrying too much about it because it's not a production app, but I am already cringing at the fact that I'm creating it here and passing it into the server, and the server is having it as a state instance. It doesn't belong there. Ideal thing is to just write a full-blown dependency injection framework that actually instantiates all these components and then injects dependencies as fit. All right. So what do we do here now? I think our app is ready to roll. I think we are at a final state here. So let's test it. Let's fire it up. Let's fire up our app. So to do that, we go into source, local taskmaster. I'll go ahead and build like we did before and run it in background. Awesome. We've got our taskmaster now running. By the way, if you are just following my thing, you're not that comfortable with Linux or Unix, Mac, OS, whatever. If you run something in background to kill it, just bring it in foreground by saying FG and then hitting Control C. That's all really that you need to do. So now nothing's running, and I can go back and run it in the background. Now, if I do not run it in background, so now it's blocking on that thing, now I can't really give it any inputs through curl, right? So what you do there is you do Control Z, and that puts it into a stop, and then you can hit BG, and what that will do is it'll take the last sort of paused app and push it to background so we can continue executing. And now we're back here. Okay, so now we're running our thing. I'm just gonna go ahead, go back, and do this in this manner one more time, so it just runs back in the background. Okay, so now that's running, we can just make sure it's running. It should be running on 8080. I'll do a -I to give us some sort of a response, codes, and headers and all that stuff, information from Perl as well. And then I'll just go ahead and do an echo. Actually, I need to hit a proper endpoint. So let's hit the task controller first and see that there are no tasks, right? And we do. We get a 200, but we get null back. So let's fix that. And we fix that by doing a post, right? And what are we posting? Let's post a JSON body, and I'm going to go ahead and post what I'm just going to call a normal task. And I'm going to call it normal task 1 because I'm going to push in more of these, right? And let's give it a priority, and the priority is going to be 25 for normal tasks, right? All right, so now I'm getting my proper created back. Now I don't have the logging and the echo anymore, right? So it's just create the task. So just the 201 that comes back. Now if we peek on that queue, we should see our normal task 1 come back to us. And obviously not giving any descriptions. Okay, so let's go ahead and throw some more tasks on here. I'm going to create urgent tasks, and urgent tasks will have a priority of 75. And I'm going to leave the 1 there because the first urgent task, right? Awesome. So we get the creation there. Now if I go ahead and peek, urgent task is on top of the pending list, right? Because it's the most important task that's there now. Just to make sure it's not just a time-based insertion order thing, next let's go ahead and put in an important task. And important tasks will have a priority of 50, right? So it's lower priority even though it's being pushed in later. And when we do that, it is created, but if we peek, we still get an urgent task back. All right, so let's get something assigned here. So let's go ahead and assign a task to our user. Now I'm going to go ahead and still use the user equals Saharsh business here, even though we know that it's actually always going to go assigned to Saharsh internally because we hard-coded that. We're not using a query param. But just keep it semantically intuitive. I'll just go ahead and do that. And as you can see, Saharsh gets an assignment, and it's an urgent task 1, right? And I can go ahead and do a get again, and it'll give me back the same task because it's not done yet, obviously, right? So while Saharsh is working on that task, the second Saharsh, let's go ahead and create some more tasks. This time I'm going to go ahead and create another important task, right? So now the 4th task that was created is the second important task. Next, let's go ahead and create another normal task, right? Normal task 2 with a priority of 25. Awesome. And then let's go ahead and create. So now if we go ahead and peek real quickly, you'll see that important task 1 is now the next hot pending thing because it was created before important task 2, and between those two, those are the most higher priority tasks, the important tasks, right? So let's change that, and we're going to create our final urgent task. And we're going to call that guy, obviously, 2. And so now, if I go ahead and peek again, now urgent task 2 is hot for somebody to take it. Okay, so meanwhile, Saharsh is now done. So we come back to our assignments controller, and we signal that Saharsh signals that he's done by saying, hey, post. And that's all I need to do. I just need to post on that controller, right? and I get an OK. Awesome. So now when I go back to the assignment controller and get the next task, you can see Sarge gets urgent task 2, even though all those other tasks are in there. So now I can keep doing this. I post it, and I get the next task, and now I get the first important task, right? I go ahead and post that. And let's do some error checking there. So I just said I'm done with it. Maybe I've done it twice. Now the service kind of gets mad at me and says, hey, you are not enabled to mark things done. Now this is not part of the response here, the first line. That's actually a log. I believe we left some logging in here. And that's probably in, if you go to common.go. That's right. So in set error response, we are having our service do the logging. And that's what that's causing. So that's why you see that there. The actual response begins here. We get a 400 bad request, and we get a nice little error message JSON that says, hey, there's no task assigned to Saharsh. I'm able to mark it done. Boom. Okay. So what was the last task we did? The last task we grabbed was important task 1. So we go ahead and grab the next one. We get important task 2, mark that done. We get the next one. I get normal task 1, which is the first normal task created. Mark that done. And then grab the next one, and we finally get normal task 2. We mark that done. And then we get the next one, and now we keep getting null because there is nothing to do. Awesome. And with that, we're at the end of the journey. Hope you enjoyed this series as much as I did making it. So as a final recap, we started off getting our bearings to the language by implementing a quick and dirty circular doubly linked list, and that doesn't even exist anymore. It used to be in this test package, right? And we stripped it out because next we matured our implementation out here, and we explored how packages and general modularity and object-oriented programming, all that stuff works, right? We did a lot of unit testing. We kept unit testing as we went through all the way until the taskmaster. We explored polymorphism, inheritance, and composition, how all those things really work out in Go. Those kind of your fundamental OOP concepts. We had a lot of fun with concurrency, and we explored mutexes, weight groups, channels, and just see what all that hype is all about in Go. And then finally, we put it all together into an actual web app by building out our taskmaster here. We just wrapped that up. So cool. With that, I'll close the series. Hope you continue your Gopher adventures. I know I will. Hopefully this had been a good jumping off point. It was absolutely one for me. Also, I hope you maybe appreciated this approach to learning programming languages. You can apply this entire exercise we did, starting with implementing the linked list and then building things on top of that in any language, really. Whatever language you're struggling to get into, do this in that language and use this as sort of like a standard of achievement. Like I need to achieve this in that language before I can say I'm functional in that language. Okay, and if you disagree, and let me know if I can do something better. All right. Well, in closing, I'll mention that I keep my blog fairly active. Well, not fairly active, somewhat active. So be sure to check back periodically because there will be other stuff there. And it's not going to be Go stuff. I just write about programming in general. I have podcasts about just things in general, just politics, pop culture, all that stuff. There's a lot going on there. Check back periodically. There's some good content. Also, all the code from this series is on my GitHub under the repo Gophin. And I've put a link in this video as well as on my blog, so check those out. And other than that, I'll just see you next time. Have a good time, guys. Bye.